What words do you learn today? Apart from none of your business. Well,
Nothing much.
nothing much, good. What's on your mind?
Sunny yesterday.
What's on your mind?
That's absolutely nothing.
Now ask me.
What's on your mind?
Nothing much. None of your business.
Oh, and what have you been doing?
What have you been doing?
And how come?
What have you been doing?
Terrible.
Nothing much?
No, I'm not doing much.
How come?
It's none of your business.
I was just daydreaming. Right, can you open up that question, the NASA question? The Kepler NASA question, remember? I think we probably should do that one. Unless you don't feel we need to do it.
Yes, you need to do it.
Do we need to do that one?
Yeah.
Yusuf, you look like you have no idea what I'm talking about.
Kepler?
The question from Kepler's lesson. Kepler's three laws.
Wait.
So, you agree it's a good idea if we do it now?
It's above.
Okay. Have you got the can you open the question there, please? We'll do it.
Did Coldplay ever come to Ireland?
I would have thought so. I'd be shocked if they didn't.
But there's a tour there going on.
They're not in Ireland for the tour?
I'm not sure.
Can you hit the...
picture?
Oh, never mind.
No, near enough.
Until now.
Yeah, you seem like a Coldplay kind of person. If someone looked at you and said, what music you listen to, it's like, yeah, Coldplay, makes sense.
They're good. Don't you agree?
No, I didn't say anything about them being good or bad. I'm saying you look like a Coldplay kind of person. Now, how does the question start? I'll give you some info in it, don't I? Sure, yeah. Come on, Omar, why are you late? Is this your first class today? Aye, and you're...
With some people.
It's okay if you're late because you're getting me coffee. Tea? Oh no, you keep it. I don't want it, thanks.
Okay, we have
Yeah, you can read the question out.
from an observatory on Earth. Mars,
Guys, listen.
Mars is observed as having two moons. One
Good.
of the moons called Phobos is observed as orbiting Mars at a distance of 9,380 kilometers.
Okay, so here is Mars and here is Phobos. And we'll call this distance, we'll call this M and this is R. Okay, go on, yeah.
And the orbit takes 7.65 hours to complete.
7.65 hours. Okay.
Finally, the radius of Mars is estimated to as 3,390. 3,390.
When I said the 9380, did I say the height or the radius of the orbit? In other words, do I need to add that to that?
No.
No. That includes it. Yeah. Okay. Great. 3390. Okay. Cool.
NASA is planning on sending a small 100 kilogram probe to Mars. Help NASA out by answering the following. You may assume a circular orbit is necessary one day on Mars is 24 hours and 40 minutes on Earth.
24 hours and 40 minutes. 24 hours and 40 minutes. Okay.
This one is estimated the mass of Mars.
Okay.
The radius is to the half of the moon? Like at the...
Yeah, it is center to center. Yeah.
Faisal and you, Mr. Klaus.
Okay. Now, what was Kepler's second law? It was T squared equals, goodness, what was it? Four pi squared.
R cubed over GM.
That's the one. And what did I want first?
Mass.
Mass of
Mars.
Mars. Okay, so the mass of Mars is going to be 4 pi squared or cubed over gt squared. Now, the or is this or, and the t is which t now? The moon's t or the Mars's t?
So what's the question asking for?
It's looking for the mass of Mars.
Mass is Mars is T.
Mars is almost
Or
because like you have to look at something to like search.
Yeah, so which one? Am I using?
I know it's 9380.
Yeah. R.
Oh wait, sorry. I just asked a question where I'm
The
asking.
time.
Yeah, sorry. Which time? Yeah. So we're using the 7.65 or the 24 hours for the time?
24.
No, the 7.65. Because Keplers law is for satellites in orbit. So the mass and the time and the radius is all for the satellite, the moon. And that gives you the mass of what it is orbiting. So if you want the mass of Mars, you need to look at the moon's behavior. Yeah? Okay, so are we clear on that? Yeah? So I open up my trusty calculator. Right. 4 pi squared or cubed, and the radius is 9380000. No.
You don't need to plot.
No, I think that question said it was the center. Yeah. The 7.65 hours. And then finally, what constant number is big G on the calculator?
39.
Oh, but what constant number?
39.
39? Okay. Nice. So, let's see what we get. And what's really nice is we can actually check online if that is the correct mass of Mars. So, okay, that seems like a fair answer, because if you remember the Earth's mass, I think it was a 10 to the 24. So it's lighter than Earth. Let's have a quick Google. Yeah. Okay. Can you just write that down, because I'm sure we'll need it later. Mass of Mars is loading 6.39 times 10 to the 23. Okay.
But it's
No.
6.39.
I know.
Awful.
Yes, but you must understand the people who calculate this use more formulas and have more data. We're just calculating it using the radius. And not only that, we're using the radius to the nearest kilometre, not to the nearest metre. And the time as well is to the nearest minute, not to the nearest second. Also, Kepler's law, just like with every law in physics, you have to assume certain behaviour, which in real life it's not exactly that. Like, for example, with the pendulum, we were talking about this yesterday, we assume its motion is actually like this. Whereas, of course, in real life, it's like this. But the difference is, by assuming this, we can use the formula. So, you know, it's a trade-off. Yeah, it's a trade-off, approximation. B part now. Oh wait, sorry, let me write this down. 6.44. Alright, what's the next part, Yusuf, please?
How fast is the moon going around Mars?
Okay, so what formula is that? Anybody got an idea?
What's total?
For what's the moon?
Yeah, how to get the V. What's wrong with wrong? Huh?
What's total?
For both.
Phobos, it's the moon of Mars.
The name of the moon.
Yeah.
Yeah, we put the mega.
The name of the moon.
Yeah, good. So what formula are we using?
The name of moon is total.
V equals omega or. Yeah.
What's mass moon?
Oh my goodness, wrong. Mars has 2 moons. And
It's not a moon.
it's not our moon. And we give a name to each moon.
Moon?
Moon, yes, moon. I know moon.
M-O-O-N.
Yes,
But why?
like Sailor Moon. What?
Why is that 2 moons?
Oh God.
Yeah, I don't know. Ask Jesus. I
But
don't know.
like in the Earth we only see 1 moon, not 2 moons.
Sorry, my physics teacher in high school, when facing this situation, his answer was I don't know, just ask Jesus, okay? Why does Mars have 2 moons? I don't know. You can ask Jesus, or Buddha, or Allah, or whoever you believe in. I don't know why it has 2 moons.
I believe you.
Hashtag new religion. No, please, no. I don't know why it has 2 moons. I really, really don't. It just does.
When he goes back home and meditates, he'll let you know.
Okay, I'll let you know tomorrow. I need to light some candles and think about it. Right. Now, you're absolutely right, Yahya. The formula is omega or, but how can we get the omega?
2 pi over t.
2 pi over t, and we know the or, so everything looks like it's in order here. 2 pi over, and what did we say the t was? 7.65? And the radius is 9380. Now that is meters per second. So yeah, 2,140 meters per second. That's about 2 kilometers per second is its speed. Fair enough? Yeah? Okay. Yusuf, what's part C, please?
Phobos radius can vary up to 10%. Approximately, what is the fastest and slowest speeds it will achieve when orbiting Mars?
Good. So, this radius here is not, it's the average radius. It's the radius if Phobos was moving in a circle. But, I said it's actually moving more in this shape. So, some parts, its radius will be 10% bigger than this, and for some parts it will be 10% less. Okay? So we can use the form, let's do the more part first. V1 or 1 equals V2 or 2. V1 is 2140. Or 1, that's V1, yeah, and or 1 is, I had it a moment ago, 9380. 9380. That's equal to V2, which is what we want, times or 2. So I'll just divide by or 2. Now, yeah, what's the difference with the radius or 2? It's 10% more. So an easy way to make it 10% more is to multiply it by 1.1. And that means conveniently I can just divide these and then take my last answer and divide it by 1.1. 1945, yeah. And we can do the same thing for this part, but you can probably guess what the only difference is. Yeah, 0.9. So if I 1926. No, I did something very wrong, didn't I? 2378, thank you. So the speed of Phobos is typically 2140, but it can be as much as 2378 and as slow as 1945 meters per second.
Where V2 is equal to that and V2.
Yeah, this is like part 1 and part 2. Part 1 is 10% more and part 2 is 10% less.
So it's faster than sound.
Oh yeah,
Way faster than sound.
way faster. You're looking at 6 or 7 times faster.
But how?
What do you mean by how? Things in space can move very fast because there's no air resistance. They're huge bodies. The scale is huge.
Yeah, but what is
Just gravity. Just gravity, yeah.
Can do 10 more.
But like
Yeah.
if an object is traveling at
Yeah.
The speed of light, that means it
No.
doesn't have mass.
Yeah.
It shouldn't have mass.
That is
It shouldn't have mass because it can't have mass. You're not allowed, the rule is you can't be travelling at the speed of light and have mass. You can't have both at the same time.
Yeah, but of course that moon has mass.
But it's not travelling at the speed of light.
Yeah.
Higher than the speed of light.
No.
The speed of sound is what he was saying.
Sound,
Yeah.
okay.
It'd be a pretty freaking cool moon if it was going
Yeah.
faster than the speed of light. That's the moon I want to be on. Because then that means as you are on the moon, you would see Mars aging backwards.
Steven, why 1.1?
You're the one who told me
I
1.1.
do not explain to you.
Increase a number by 10%, multiply by 1.10. Increase by 20%, multiply 1.20. Increase by 30%, multiply 1.30.
Decrease
Why?
by one.
Why? What do you mean why? Why? Come on. Alright, I have €100 and I want 10% more. How do I do that?
Plus.
Yeah? 10. How did you get 10? So for example,
No. Plus 10 over
100
100.
times 100.
You said.
okay, €200, I want 10% more.
Plus 200
Yeah.
times 10 over 100.
Okay, if I take out 200, I'm left with 1 plus 10 over 100. What's 10 over 100? 0.1 plus 1.
Nice.
Nice. Yeah.
So this is the password.
Yes.
What about less?
What do you think?
0 point something.
Yeah. 10% less is 0 point?
1.
No. Try again. 10% less is?
9.
Yes. Correct. Good. Okay. D.
Density of force.
Density of Mars. So density of Mars is its mass over its volume. What did I say the mass was earlier? Let me see. 6.44 times 10 to the 23. What shape is Mars? Roughly. So the formula is
4 over 3 pi r.
pi r cubed. And I gave you the R as well, didn't I? 3390. Thank you, Yusuf. Cubed. I'm expecting an answer somewhere in the hundreds. I don't know, 500.
So if someone was traveling at the speed of light, they live forever? Like they live until they were born?
No, the time will pass normally for you. It's the rest of the world that will be moving backwards.
3946.4.
Indeed, thousands, sorry. 39.
46.4. Or you can write 0.37.
I will not write any point, in fact.
Will you be able to see yourself being born?
Yes.
But then you're on the...
No. Interesting. Yes. You'll see everything moving backwards.
But then you're on the thing. So
That's true, actually. I don't know.
That's true.
Just because you're seeing it doesn't mean you're living it.
That's true.
But then you're on it.
But you're moving backwards in time.
So what? You're not doing anything with the time. You're not playing with it.
You're just watching it.
Yeah.
There's only one way to find out. To the physics lab. Right, what's next now?
What is the gravitational field on the surface of Mars?
Great, so that's G equals GM over R squared. One. Focus please. R cubed is it? Thank you. Is this the right formula for G?
Wait. No.
Isn't GM?
Square or cube? It is squared. Okay.
Isn't GM?
Isn't this it for?
There's GM and
GNM.
No, for the gravitational field strength.
and then there's
That's it, yeah. So, shift 739. Now, sorry, is it Mars they want it for? So that's, or Phoebus? Or Mars?
Mars.
No.
3390. So you can see much less, well, yeah, a good bit less than Earth. 3.74 instead of the usual 9.81. So, newtons per kilogram. This means on Mars, you're less than half your weight. Which means, if you think about it, you can jump twice as far. You know, lift things twice the mass that you could on Earth. So if you could bench press 100 kg, no, what am I talking about? If you could bench press 20 kgs on Earth, then you can bench press 40 kgs on Mars, because its weight would be less than half of what it was on Earth. 100 kg, who am I kidding?
you might be able to bench press 100 kg on Mars.
On Mars, that's like bench pressing about 40 kg. That's more believable.
There's a spider.
You're Spider-Man now.
Yep.
Well, if you want it.
No, thanks.
Okay, what's the next part now?
What is the altitude of the working orbit for the probe around Mars?
So we can go back to Kepler now and have t squared equals t squared equals 4 pi squared or cubed over gm. Now the Mars time is 24 hours and 40 minutes. And we know the mass, so we're looking for the radius here. So the radius would be gmt squared over 4 pi squared gmt squared cube root. Okay, so let's hit that in on the calculator. Cube root what was the mass?
6.44.
1023.
Yeah.
And now the time was 24 hours, correct? Plus 40 minutes. Exactly 40 minutes?
Yeah.
So there's 60 seconds in a minute, okay. Now, did I ask? Now, altitude. Another word for altitude?
Radius.
No?
Height.
Height. Altitude means height, so I need to minus the radius. And what was the radius of Mars? Yeah. What was it? 39, was it something? 3390, yeah. So if I minus 3390,000, I'm left with this. Let's make it kilometers. 17,086 kilometers. No, that's the satellite's altitude to be in a parking orbit. Yes, what's next now? When you're ready.
What's the gravitational field strength on the probe when it is in a working orbit?
Great, we'll calculate that. Just before going on, to put it into context, for Earth, the geostationary orbit, the parking orbit, altitude is about 36,000 kilometers. So actually, although this number seems big, it's half the altitude you would require to have a parking orbit for Earth. Why do you think the reason might be for this? Well, what's different in this formula? Yeah. Oh, to be more clear, what's different in this formula that's making the ore smaller compared to Earth?
Gravitational strength.
Yeah, in this formula right here.
Time.
No, the time is about the same. It's the mass.
The mass the same as the first.
Yeah, no, but what I'm saying is, comparing Mars and Earth.
Oh, compare.
Yeah. For Earth, the altitude is 36,000 kilometers. For Mars, it's 17,000. The reason for the big difference is only because of the mass. Because everything else is the same or nearly the same. G, 4, pi, t, not much difference. It's only the m that's different. So because the mass is less for Mars, it means the altitude is less for the parking orbit. Okay, what's next now? You said calculate the... Right, so that's gm over... Now, I told you that the probe is 100 kgs, didn't I? And the radius is 17086,000 plus 3390 again. So, should this be bigger or smaller than the answer we got earlier for G?
Bigger.
Smaller. Because it's further away. Yes. Oh, sorry. I'm so sorry. That mass. Thanks, Yusuf. You made me realise I have the wrong mass in here. It's the mass of the planet, not the probe, which is, what was it?
6.44.
Okay. This should be less because you're further away from the planet, so you have less gravitational field strength. Only 0.1 newtons per kilogram. Yeah.
Less because of the mass.
This one's less because you're further away from Mars. Okay, is there more?
What's that formula? Did you take that formula?
This came in gravitational fields, not in Keplers. Next.
What's the total energy of the probe when it is in a approaching orbit of Mars?
Whew, I made this question huge. Is this the last part? Oh, thank goodness. Total energy is potential energy plus kinetic energy. Now, the kinetic energy is easy. That's a half mv squared. The potential energy is negative because it's trapped. So that's g m over r. Yeah. Now, if I look at this formula, there's only one thing I don't know. Y minus? Y minus.
Oh,
Okay. What's the only thing I don't know in this formula? The v squared, yeah. But remember, v equals omega or. Now do I know everything? Well, nearly. How can I get omega? Yeah. Now do I know everything? Yes, I do. So, firstly, it's a half. Oh my goodness. Times 100.
It's kilograms. Don't you have to change?
It makes me happy when you answer your own questions. What is the radius of the orbit? We said it was, my goodness, what was it? What was the parking orbit? High altitude? 17,000?
17,086.
Yeah, and then the radius of the planet? 6. 3390. Okay, and the time was, oh, of course, it's in a parking orbit, so it's 24 hours and 40 minutes.
You're not multiplying by 1,000 the distance.
Yeah.
Ah, thank you! Thank you. That would have been embarrassing. No, too far. Thank you. Okay, next, I need my minus GMM over OR. Minus G, what was the mass of Mars? 6.44 times 10 to the 23, and the radius again is the 17086,000 plus, yeah, 3390. Oh no, I ran out of space. No, actually, I know what I'll do. I'll change this 23 to 25 and get rid of the 100. That'll free up a few characters. Okay. And then, how many O's do I need? What was it, 3? Yeah. I need 3 more O's, don't I? 1,
Why you
2.
not have 10 to the power?
Huh? I know. I'll change this to 50. That'll free it up. Right. 1 more O. There you go. So the energy is negative because the potential energy is so negative, because it's trapped. Let's put this in giga. That's mega. That's giga. No, a bit too big. Mega. Minus 105 megajoules. Now, what did you think of that question? Long? That would be like a section B question, as you can see, because of the multiple parts. The fields question in the exam, I don't know, they come in 2 flavors. You can deal with electric and magnetic fields, or sometimes they ask gravitational fields. So you have 2 types of field questions in the exam. I suspect you probably prefer the gravitational field than the other ones. And that is what the September students got in their exam. Again, another reason for why it surprised me that they did so badly, because they got all the right things you want to get in an exam. They got a gravitational field, they got a projectiles in mechanics, they got a materials question with the ideal gas law, all the stuff you'd want to hope to get in an exam.
That was for section B?
Yeah.
What about specifically for processing?
That was in there in materials. There was only one hard question.
Does that mean that section A was hard?
No, usual section A. Like, the first question was your standard scalar and vector question, like a boat does this or a car does this or whatever. No, I think the first question was conservation momentum, I think. The collisions, you know.
Business does Stephen, Lee and I were in the class.
Yeah, like,
No, he said it's at 11:12.
So it's 7 minutes to go. 11:12. Yeah, too late, dude.
That is something that they
Okay.
Or physics class not 11 to 12. We have chemistry.
You have chemistry for the rest of the day? Oh yeah, that one.
We have sheet.
11, 12 is.
And then back home to hit the books? Or another season of Friends?
Wait.
What?
It's 11:43 now.
Yeah.
Yeah, so 11, 12 was when the lesson started.
Yeah.
11:07 really.
Like we started at 11. I just want to everything else.
Don't worry, I do not worry or care. Don't worry about Faisal.
What about you?
What about you?
Oh, is he okay? Did something happen to him? Is he
I
okay?
think he lost his wallet.
Did he really? Did he try calling pennies? I hear this is where lost wallets turn up.
Just now he lost in the classroom and he went back.
Yeah. Oh yeah. After 2 months. Okay. Yeah. He lost his wallet.
He left it in the classroom and he went back to find, but he couldn't find it.
Oh dang! And he has a GMIB card in there.
Yeah, he does.
Probably.
This classroom?
Did he have 200 lucky dollars in there too?
Highly doubt that.
Yeah, he hasn't bought a frappuccino in a while. I think he's saving his cash. The last time he had a frappuccino was like 2 months ago.
Pink one.
Maybe she didn't bring it.
Maybe.
No, he came.
Okay, now that reminded me to ask you, next week there's a tiny change to the timetable so that we can have a 3-hour class because the principal wants me to have the option of giving you a practice test. And I said, I will ask my students and see if they would like this. So, I'm asking you,
Yes.
would you like this?
Yeah.
Yes.
Good.
When?
I don't know what day, I think midweek, I think.
Do we need 3 hours for the test?
Well, it's
How long?
it's
2 hours.
2.5 hours, so you can do the test and then go then. I mean, we won't start exactly on time because I'll have to give out the exams, you'll have to get your stuff ready, and it's actually then you have 10-minute reading time if you want to as well. But the real question is, which subject?
Only one. Only choose one.
There's only one 3-hour block she arranged for me.
Math.
Definitely physics. Definitely.
Right, let's get a straw poll opinion here.
Physics.
September.
Physics,
Math.
maths,
I'm struggling
don't
with
mind.
maths.
Maths you would prefer the test?
I'm struggling with maths. What is that?
Good question. What are you trying to get from the test? There's 2 ways you can think about the test. You can either do it as a way to see if your studying is going to plan, or you can do it to see, well no, I guess the key thing is to see if your studying is going to plan. So if you already know the maths is a problem, then there's no value in doing the test because it's just confirming something you already know. But if you feel like your physics is going well, it will be good to do a test to test this idea.
So physics.
Oh, math.
Okay, so physics now.
Maths.
Right. Maths, okay. Physics.
Physics.
Omar? Maths. Physics. Okay. So we'll have a practice physics test next week, and not only that, the practice test I will give you will be the September students test. So this is a test you haven't seen because it's.
We have.
How did you see it?
We take pictures.
Oh yeah.
They didn't see the math.
I forgot that. Did you not see the maths one?
No.
Well, have you tried that practice test? Good, okay. So, I mean, of course, there's nothing to stop you from looking at the test, but I would recommend to try and do the test in the spirit of seeing how much you know. Yeah? Yeah?
So it's going to be September student test?
Yeah. Or not, I can give you a different test if you want. It's just, I feel like this would be the most accurate practice test you could do, because the person who wrote that test will be writing your test.
Could you change the prism question to a circuit question?
Good idea. Yes. To test your circuit knowledge. Because I don't think you weren't in the office yesterday when I was talking to Andrew, but I was saying